Greetings! This is Unit 7, Module 1, Session 6. The name of this home connection is Sketch and Compare Fractions. You should really put your name and number at the top so we can get rocking and rolling. This is the first time that I've seen this typo, but normally it says page 1 of 2. It does not. Although the second page, if you flip it over, it will say page 2 of 2. So that's kind of interesting. That's the first time I've seen that. Anywho, let's get digging into this. I'm going to turn my highlighter on here so that you know what I'm looking at. This says sketch and name two fractions that are equivalent to 2/3. If you're used to messing with numbers, maybe this won't be too bad. But what I'd like to do is think about this 2/3 right here. What can I do to these numbers that is the same? Can I cut them in half? Well, not easily, because we like to work with whole numbers here, right? I could cut the 2 in half, but if I cut the 3 in half, it's going to be kind of messy. So instead of maybe cutting in half, what could I do? Could I double it? Absolutely. Sorry that didn't look really good. And don't forget, whatever you do to the denominator, you have to do to the numerator. So if you double one, you have to double the other, which would give me 4/6. So if I doubled it, what do I do down here with A? I know that I'm going to write 4/6. That's okay. But what do I do to these pieces? Because right now these are thirds. We want sixths. I need twice as many. So shouldn't I just maybe cut each one in half? Now what happened? It looks like I now have 6 pieces, okay? And now I can shade 4 of the 6 in, and I'm going to use maybe a lovely red. There's 1, 2, 3, 4. And look, our fraction is still equal. This shaded area is the same size as that shaded area. So we did that correctly. What if I want to do that again? Ooh, what should I do? What should I do? What should I do? I could triple, right? Maybe I could do that instead of doing, I'll maybe write this over here. So I'll write my 2/3. That's my original number. And then I'm going to triple them. Triple. And I could quadruple them. I could take them times 10. I could double the double, right? Take them times 4. I'm just going to do times 3. 3 times 2 is 6. 3 times 3 is 9. Oh my goodness. Well, when I doubled this up here, right? When I doubled it, I ended up cutting each one of these in half. But now that I've tripled it and I've got to cut this into 9 pieces, well, each one of these has to be 3 pieces. So I kind of have to space my lines up, and I'm going to add kind of 2 to each block. Add kind of 2 there, 2-ish there. That's as close as I'm going to get with my non-artistic drawing. But I do have 9 now, so that's good. And now I just need to highlight 6 of them. Maybe I'll do this one in a lovely blue. 1, 2, 3, 4, 5, 6. And what do you know? I now have that fraction equivalent. And look, it's the same size as that one. Yay! We did it. But like I said, you can divide this however you want. You can take it times whatever you want as long as it matches. But I will say, if you took it like times 100, you're going to be drawing lots and lots and lots and lots and lots of lines. So maybe it's better that we doubled and tripled instead of doing something really wacky. This says sketch and name two fractions that are equivalent to 3/4. I'm going to let you do this on your own only because I've given you a great setup, right? You could take 3/4 and you could double it, okay? You could take 3/4 and you could triple it. And then just make sure that when you add your lines, you add them appropriately. If you're going to double it, you need to add one line in between each. If you triple it, you're going to add 2 lines in between. And I bet you know that if you quadrupled it, you'd have to add 3 lines in between, okay? Because you need the bottom number. The bottom number tells you how many pieces there are. Just like the 4 here tells you that there are 4 pieces, and the 3 tells you how many of them are shaded in. So 3 of the 4 pieces are shaded in, okay? Pause this video and work on it. Looks like we need to rewrite 2/3 and 3/4 with a common denominator. We did this on the last homework assignment, and I hope you liked the way that we did it. Where's my highlighter? I'm going to look at these denominators, 3 and 4, and I'm going to figure out what common multiple they have. And if you want to do it very systematically, then set up a little multiples table have a 3, have a 4. Ooh, I have an alarm there. And then we can count by 3s until we find the answer. So I say 3, count 6, add another 3, 9, add another 3, 12. And let's go over to this side with our 4s. So 4 plus 4 is 8, plus 4 is 12. Ha 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 ha, look. I just found a common denominator. 12 is the first number that you have in common when you start at 3 and count by 3s and start at 4 and count by 4s. 12 is going to be our new denominator. So I'm going to write 12 on the bottom right away. Okay? Now, come with me. If I look at this, I have to say to myself, 3 times what is 12? Well, 3 times 4 is 12, which means I have to say 2 times 4 is going to be my top number, because we know that whatever you do to the bottom number, you have to do to the top. 2 times 4 is 8. So the fraction equivalent of 2/3 is 8/12. Now, stay with me. Let's come on over here. Same thing, different question. 4 times what is 12? Well, 4 times 3 is 12. And if you do that to the bottom, you have to do that to the top. 3 times 3 is 9. So we know that these two numbers, 8/12 and 9/12, are the fraction equivalents of our first numbers. Now we're going to compare them because we have a common denominator. 8/12, 9/12. Which one's larger? 9/12 is. 9/12 is the equivalent of 3/4. So we know that 3/4 is our larger number. So when we write this, I don't know why the lines are so big, because we only have to do 2/3. We're just bringing this number down here. And then I'm going to take this 3/4 and bring it down here. The alligator eats the bigger number. We know that this number is bigger because we found the common denominator so that we can compare them. Let's go on to the next page. As promised, here's page 2 of 2. Isn't that weird that they missed that out? Those little details we notice. It looks like we are going to be sketching and naming 2 fractions that are equivalent to 1/4. Later on, same page, we're going to be sketch and name 1 fraction that is equivalent to 3/10. You're going to have to do some dividing of these. If you remember the last home connection, they kind of divided them for us a little bit, and this time we're going to be adding our own lines to it, splitting them up a little bit. What if we did this next one in reverse? I'm going to do one of them. How about I do A? I'll do A. So I'm looking at 1/4. You know, I'm going to split each one of these in half. Okay. I am going to now count the pieces, but we should know that if I split each one of these into 2, I'm doubling it. So instead of 4, I have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I know that's my bottom number. I'm now working with eighths. And then what do? Well, I'm going to highlight or shade the exact same that was up here, right? So if I shade the same number here, or amount here, how many eighths do I have? 1, 2. I had 2 eighths. That is also the same as, bring it in here, bring it in here, bring it in here, as if I doubled it, right? So if I took this 4 times 2 and I took the 1 times 2, I'd get my eighths on the bottom, I'd get my 2 on top, and look, they're the same. I just did it a little differently, okay? And you can do that as well with yours. I'm going to let you do B on your own. You're going to do another fraction that's the same, an equivalent fraction. Same amount shaded, just different number of pieces, okay? Let's do down here. Now, the reason that this one maybe only has 1 fraction equivalent listed here, just 1, is that if we double the 10, we get 20, right? And that's like this, that's the next larger number that isn't out of control, because we can only double, and then after that, you have to triple it, quadruple it, that number is going to get huge. So if you split all of these in half, and I know that I'm not super precise, but you can understand the gist, is that I broke each box into 2. So now I have a bottom number of 20. I'm going to let you shade in and figure out what that numerator is going to be. Okay? Now, we're going to compare the fractions by finding a common denominator. I feel like we've done this several times at this point, and I'm not upset. I'm not feeling like you can't do it, but just so that I know, we have 4 and we have 10. Okay. Whew. This is where it gets a little bit challenging, but you're going to set up your ratio table just like you did before. Not a ratio table, but like a table of multiples, right? I'm going to count by 4s and I'm going to count by 10s. Well, if I count by 4s, then I have 4, 8, 12, 16, 20. I'm going to stop there. Because if I count by 10s, so over on this side, 10, why did I just write that? 20, and ooh la la, look at this, look at this, look at this. There is my common denominator. I can make each one of those balance out to have a denominator of 20. So when I look at these, I'm going to zoom in a little bit, okay? What color do I want? Maybe red on this side. If I take 4 times 5, that's how I get a 20. Why did I write 50? Oh my goodness. 20. And then whatever you do to the bottom, you have to do to the top. So you're going to take that 1 times 5 and you get 5/20. Yay! And then on this side over here, if I take 10 times what? I'm trying to get 20 on the bottom. So I'm going to take 10 times 2. Whatever I do to the bottom, I have to do to the top. So 3 times 2, 6. So it looks like if we have the same denominator of 20, we have 20ths. We're cut into 20 pieces, okay? 1/4 is 5/20. 3/10 is 6/20. Which one's bigger? Well, before it was hard to compare 3/10 and 1/4. Oh, I don't know, right? But now that we have 20 on the bottom, we have the same number of pieces. Well, 6 of them is more than 5 of them, right? So we know that 3/10, also known as 6/20, is bigger than 1/4, which is also known as 5/20. So when you rewrite your equation, which you should, 5/20. Ooh, no. It wants to know which one's bigger, 1/4 or 3/10. Well, we just said what? We said 5/20 is 1/4, 6/20 is 3/10. We know the alligator eats the bigger number. Nom nom nom. Alrighty, rewrite each pair of fractions with a common denominator, then write a statement to compare them. We basically did this if so. Look at this if so right here. If 5/15 is less than 6/15, then 1/3 is less than 2/5. We know that's true because they basically figured out that 1/3 is 5/15, and that 2/5 is 6/15, which is right here. Okay, and we know that 6 of them is greater than 5 of them, so the 2/5 is greater. That's what we did up here. We found the equivalence and we figured out which one of those was bigger. I'm going to do one of these, and then I'm going to ask you to do the rest. I'm going to actually start with a challenge, okay? So we're going to find the fraction equivalence with the same common denominator, okay? So what am I looking at? Get my highlighter out just to point out that I'm working with 7 and 5. I'm trying to find which number they have in common. I'm going to look at multiples. So if I count by 7, 14, 21, 35. Ooh, ding, ding, ding. I see a 5. Count by 5s. 5, 10, 15, 20, 25, 30, 35. That one actually wasn't too bad to figure out what the common multiple is. So this is the denominator we want both of those numbers to have. Now I'm going to zoom way in. If 35 is the number we want, how do I turn 7 into 35? Well, I'm going to take that times 5, which means I have to take that times 5. How do I turn 5 into 35? Well, I'm going to take that times 7, which means that I have to take the top number times 7. If I do that, what do I get? And I'm going to kind of move this a little bit. I'm going to write my answers in a different place, in blue. 7 times 5, 35. That's the number we were looking for. 3 times 5, 15. On the other side, 5 times 7, also 35, the number that we were looking for. 2 times 7, 14. Now I can compare them because I know I have the same denominator. So 15/35, well, that's more than 14/35. So when I draw my symbol, the alligator is going to eat that number. And if you want to use the example that they gave you to help set up your problem, you could. I don't want this to be too small. It's kind of hard to see on this screen. But you could say, set up your problem like we did, okay? Set up the other like we did on this side. And then you compare the ones. So you'd say 15/35 is greater than 14/35, which tells you that 3/7 is greater than 2/5. Okay, and you can watch this problem again if I spoke a little too quickly. I feel like I'm a little jazzed about this math. But if you need some, watch it a little slower, turn the speed down, okay? You can also rewatch. You can pause to do the steps with me. But your goal is to make sure that you have the same denominator. So you have to look at multiples of 6 and 8. Here you'll have to look at multiples of 6 and 4. Set up your little chart. Find the number that they have in common. And then multiply them to make them agree. We've done this several times over the course of this worksheet. I think you are going to nail it. But if you have questions, find a math wizard. Your teachers love to help with math. Check you later.